We're a stressed country. I think we all know that. I believe we're the 30th driest country globally.
You look at Hartbeespoort Dam, it's probably our biggest single water issue in the country.
And they are seeing everything from increased hormones, drug residues, and ARVs very prevalent in waterways and river systems. And we know that that is coming from wastewater, and conventional wastewater treatment plants are not designed to remove those contaminants.
Our plants were never designed to deal with this.
As a country, we're dealing with that infrastructure failure. There's corruption and general lack of respect for environment. Nanobubble technology gets us beyond 85% transfer efficiency. So when nanobubbles exist or are produced into a water body, it switches on that beneficial bacteria, the good bacteria, and it switches off the undesirable bacteria, the E. coli and pathogenic species.
South Africa faces mounting challenges in securing reliable and sustainable water supplies, yet innovation is showing us that solutions can be found where nature and technology meet. From ecological engineering to advanced biotech, new approaches are reshaping how we treat wastewater, restore ecosystems, and accelerate the natural water cycle. This is the Safripol Water Security Engagement Forum. I'm your host, Michael Avery, and today I'm joined by two pioneers, really, from Blue Planet South Africa. Heiner Dominick, the founder and managing director, whose vision and engineering expertise have really driven environmental solutions around the globe, and Rowan McDonald, who's head of technology, whose focus is on bioremediation and nanobubble technology. It's certainly bringing fresh thinking to our polluted rivers. Together, we're going to explore how engineering and nature can work hand in hand to build resilience for South Africa's future. A bioremediation architect. I can't wait to get stuck into that and what that actually entails. But Heiner, maybe you can just from a very big picture perspective, share what the current state from your perspective is of South Africa's water system from a kind of a resilience and a systems infrastructure perspective. How are we doing?
We're not doing very well. I think we have a very integrated water system. That means we are reusing our water quite often. We have a serious amount of nutrient bulking taking place in our natural waterways, which one act as our drinking water, but they also act as irrigation water, these water bodies. And, over the years, through systematic failure of a part of that integrated water reuse, we are starting to see the real effects of that out in nature.
Nutrient bulking, for those who are not steeped in the terminology in the industry, what does that mean?
Nitrates, which are detrimental obviously to human life and animal life at elevated levels of up to 25-30 milligrams per litre in aquifers. Not sustainable. Phosphates, very, very high levels of phosphates, nitrites, and a host of others as well. So these are very difficult to remove once in a natural water system.
And 25 milligrams versus what should be the normal natural level? 4-5
milligrams.
Wow.
Wow. So it's extremely high. It's sometimes 5 to 10-fold of what it should be.
Frightening. Rowan, what would you say from your perspective is the current state of our water system?
So speaking on resilience, I think there's two ways to view that. There's resilience in the form of volume and demand required by users. We're a stressed country. I think we all know that. I believe we're 30th driest country globally. We're predicted to exceed for supply to have supply issues in the next sort of 5 years in South Africa. So we have a water scarcity issue, but the water quality in terms of resilience over the years, natural water systems and natural waterways, the biology inherent to these aquatic ecosystems has got the ability to deal with a certain amount of nutrient and a certain amount of loading. Decades ago, when you were discharging treated wastewater into a waterway, it would essentially be attenuated and diluted and not create an issue. But with rapid urbanization, a lot of complex man-made chemistry now, we're starting to choke the biology of these systems and basically overload them. The water has lost, a lot of surface water and a lot of water bodies has lost the ability to cycle and manage that nutrient load because it's essentially overloaded. We've gone too far.
Right. It's almost like your natural filtration systems that wetlands and other things have been overloaded with these nutrients. Think of a pool filter that becomes gunged up and just can't take anything more, for example. Where are we seeing the worst examples of this, Heiner?
Oh, there's a whole host. I think Rowan will probably speak to one of the issues at the Soot River down in Cape Town. You look at Hartbeespoort Dam, it's probably our biggest single water issue in the country, that's receiving in excess of 600 tons a year of phosphate from dysfunctional or poorly functional wastewater treatment plants, AMD, and a host of other sources discharging into a river system, landing up in these large water bodies. The Vaal Dam is also no longer protected from this. If we have a look at the water lettuce issue last year and the year before along the Vaal River, and this is mainly due to nutrient bulking, and that's affecting ecotourism, tourism, livelihood of people living along those areas that rely on these jobs.
Yeah.
So it's a massive impact.
And as we know, obviously, Hartbeespoort Dam and the hyacinth issue, which is this recurring problem that we do see. Rowan, you're at the bleeding edge of bioremediation tech. What does this merging of natural processes and advanced technology actually look like in practice?
When we talk about bioremediation and the integration of technology, really what we're trying to do is accelerate the water cycle. So the water cycle, if we think about it in simple terms, it's the evaporation and precipitation of water between the oceans, the rivers, lakes and dams. But along that route, while that water is still on land, it is up to beneficial biology or beneficial bacteria to deal with those nutrients we speak about and degrade other pollutants. All right, so this is very similar to what is essentially supposed to happen in a wastewater treatment plant. The workforce are bacteria. All right, so a lot of people get scared when we talk about bacteria in water because you think of pathogens and E. coli. Those are the nasties, but essential to almost all forms of natural water and wastewater is a workforce of good bacteria. And what we do with that overloading that we've seen from man-made activities and an immense amount of chemistry and drugs that land up in the water, these act as inhibitory compounds to that microbial workforce. So our job is to augment a water system, bring back that beneficial biology, and essentially give it a helping hand. So it's still natural processes, but because of that overwhelming loading and the immense amount of chemistry now in our water, we need to supplement and we need to support that water cycle with technology and naturally occurring bacteria.
What does that look like in practice? Maybe you can take me through an example where that kind of biotechnology has been really effective in giving a natural system that boost it needed.
So the two cornerstones of how we implement a bioremediation project come down to the supplementation of those beneficial bacteria. So we have facilities and products where we have registered microbial strains that exist naturally in nature all around the world. We know exactly what they are. We haven't engineered these microbes. We've literally collected and grown them in special facilities, boost their numbers, combine them in a consortium where they have multiple modes. A specific bacteria will deal with ammonia, a specific bacteria will deal with phosphorus, and they all have different jobs to do. So our unique approach in this is the ability to get that consortium together to deal with a host of problems in the environment or in a wastewater treatment plant. And then the rest of it comes down to providing that workforce of bacteria what they need. And what they need most of the time is oxygen. So we've got to have novel means to introduce oxygen into water, be it in a wastewater treatment process or a river or a lake or a dam that's been impaired.
Right.
And when we condition that water and get oxygen in an efficient manner, because getting oxygen into water is typically very, very energy intensive. We do that efficiently. Those two combine and get that microbial workforce restored so that the pollutants are degraded and the nutrients are cycled.
Fascinating. I mean, how do you do it in an energy efficient manner? I mean, one thinks of just how energy intensive it is to put one of those bubble stones in your pond, for example, at home. But to do it at this scale in a river or a lake or a huge water source, what does that look like?
This is something that basically wasn't feasible decades ago. A few years ago, Heiner was dealing with some challenging environmental issues. A job that needed oxygen. It was a large-scale project. How do we do this cost effectively? And basically, we started working with nanobubble technology. Nanobubble technology is a means to get that oxygen into water highly efficiently. Most aeration or bubbling techniques, as you said, would be at about 3 to 7% actual efficiency of transferring gas into liquid.
Oh, very low.
A lot of wasted energy. When you're talking about something at scale like Hartbeespoort Dam or other large water bodies, it wasn't viable. Nanobubble technology gets us beyond 85% transfer efficiency. So we can now selectively and efficiently get oxygen into any size water body. But so too, the bubble size and bubble form gives us a lot of other benefits. So nanobubbles are bubbles so small that you're not going to see them in water. They don't rise out of water like a conventional bubble. So if we think of a bottle of soda water, those are approximately 1 ml bubbles. They want to rise out of the water. 100,000 of our nanobubbles will fit inside one of those bubbles.
Sounds like a Guinness. You're making me thirsty.
So at that scale, they've now taken on a completely different trait. They're not just a provider of gas. They're actually a catalyst to accelerating that biology that we want. So when nanobubbles exist or are produced into a water body, it switches on that beneficial bacteria, the good bacteria, and it switches off the undesirable bacteria, the E. coli and pathogenic species. So it's really just an awakening of what we want in that system, and having this high efficiency means to give the oxygen that microbial workforce wants. That's their paycheck to get to work, and the ability to do this at scale and start controlling and reducing those inhibitory compounds which caused a lot of this problem in the first place.
How did you come across this technology? I don't know, Heiner, if maybe you want to share that. And then how do you introduce those nanobubbles into a water body or source?
In 2014, as Rowan said, excuse me, I was exposed to an issue with a client. We required oxygen at depth. We had a lot of sludge to deal with, sludge that was holding a lot of these nutrients and heavy metals and some other constituents. And I came across, after some research, nanobubbles. I was also introduced to somebody that was producing a nanobubbler, and we decided, okay, we're going to now try and combine this with our biological approach, with our bio-augmentation approach. And we started seeing the real benefits of actual symbiosis between the nanobubble itself and the microbes, and what was happening, particularly on the enzymatic front, on the enzyme front. All of a sudden realizing that we were doing a job in a third of the time, in a quarter of the time that it would normally take, at a much lower cost. And then started looking for who were the world leaders that were emerging, and then we partnered with a company in the USA who are 13 or 15 PhDs on staff researching nanobubbles. And so that journey grew. So it's a 12-year journey already. A lot of learnings over those 12 years. And, that's where the bionomics approach that we use was born from, is understanding that symbiosis between the two.
Oh, fascinating. Conversely, are there any areas in that 12 years where you've discovered maybe this isn't the best approach, or sometimes nature pushes back in some unexpected way?
No, I can't recall a a situation like that. At the end of the day, our approach is always nature first, work with it, not against it. Right. I think what we do see in industry in terms of technology failure or where technology can cause challenges is, as a society, the engineering and science fields have developed some incredible chemistry, functional chemistry, to deal with disinfection in food processing and in hospitals. The drugs that people take, those are amazing technologies. The secondary effects of those in water are causing a lot of challenges. So we will refer to those as persistent organic pollutants or contaminants of emerging concern, CECs. At the end of the day, these are all inhibitory compounds to the way nature wants to work. We've found technology in the form of nanobubble technology that is fundamentally natural. Yes, it is engineering and technology, but the existence of nanobubbles, they were discovered first about 30 years ago in crashing ocean waves in certain rivers. So they do exist naturally. We don't have enough of them to deal with our problems. And that's when we entered the engineering age of, right, we understand nanobubbles are very useful in the water cycle and in water treatment. How do we create them on demand?
Yeah.
And in mass.
Yeah. I think there might be a lot of myth and concern about these, emerging chemicals of concern. Obviously, in a country like South Africa, where our wastewater treatment plants were designed decades ago, many in the 60s and 70s, now breaking down as well. There was one myth doing the rounds a couple of years ago that there's now, because of the pill not being filtered out, that there's increased levels of estrogen, for example, in our drinking water. Is that a pervasive myth? What are some of these emerging chemicals of concern that we do need to be worried about?
In South Africa, we're fortunate enough to have very decent academic research on that front, particularly out of Western Cape, where there's direct discharge to ocean. There's a lot of studies going on with the aquatic species and biodiversity in the coastal region. And they are seeing everything from increased hormones, drug residues, ARVs, very prevalent in waterways and river systems. And they are, to sort of put one example out there, they are finding one of the active ingredients from a skincare product on penguin eggs on islands off the coast. Oh. So, and we know that is coming from wastewater, and conventional wastewater treatment plants are not designed to remove those contaminants.
So what's the solution on that front then, Heiner? Do we need to retrofit all of our wastewater treatment facilities?
Well, I don't think.
Working first.
I think I just want to add to something to which the previous question first. Yeah. One of the biggest problems that we have in the country is, and not just in South Africa but globally, is surfactants and quads. These are inhibitory compounds found in everyday soaps, everyday cleaning material. So as EPA guidelines in the US and everywhere else get stricter as to cleaning regimes in food production. So we see more cleaning process, CIP happening, more chemistry is used. This chemistry is usually based on ammonia, based on phosphate and phosphorus. So we have this huge increase in all of these products that is being used. Even our personal use has changed. I remember as a child we had one bottle of shampoo in the shower. Yeah. Today I fight for space between all the bottles. And these are all surfactants, and our plants were never designed to deal with this high load of surfactant, and hence the energy that is being put into aeration to aerate these biological wastewater treatment plants is going to break down these surfactants, and is not actually breaking down or supporting the microbial community within that plant to do its job of stripping those nutrients. So that is really where we've come in, and we said as a pre-treatment we can remove those surfactants through the action of the nanobubble and the chemistry that happens with the nanobubble, and with that able to support these wastewater treatment plants that the oxygen goes to where it needs to go.
Just the state of our wastewater treatment facilities, and I think we're all very well aware that across the country, there's some that are performing better than others, but in the main, I think we would struggle to give the system a pass mark at the moment. So many are failing here in the cradle of humankind. It's a very knotty, complex problem. Rowan, what do you see as the root cause of the failure to deal with something that seems so obvious and relatively straightforward to fix?
Yeah, complex topic, many inputs to why the breakdown is there and what it takes to fix. As a country, we're dealing with that infrastructure failure, relating obviously, there's corruption, there are in some, in terms of operations, lack of skills transfer, robust management, and general lack of respect for environment. We have a fairly robust environmental rule set in South Africa. We're actually famous for a good rule book on how we try and protect the environment and how we monitor it. Yeah. But the enforcement's not there.
Yeah, NEMA.
And
Exactly.
the relationship between water utilities, the departments and municipalities is complex and doesn't really encourage or allow this enforcement and a direct action. It's very challenging.
That space is also very politicized. So when it's politicized, it becomes very, very difficult to solve. And then lastly, I think poverty plays a big role as well in this, which leads to the theft of cables, there's organized crime in this too, of course, but it leads to this opportunity theft. To gain a piece of cable where we're going to get 20 rand at the scrap dealer is causing millions and millions and millions of rands of damage. And it's that education of getting that message across that this is for the community's good.
It's very interesting. There was a conversation we had with Gift of the Givers, and one of the successful learnings from installing boreholes at schools, for example, there was one at Port St. John's that hadn't had running water, this community, for 5 years. But they found that if you install the infrastructure at a school or close to a school and you get the community buy-in from the parent body and the principal, the infrastructure is generally not vandalized. The community understands the value of not having to track 5 kilometers down a hill to get buckets of water, from where the cattle are drinking. And so, there's a way to think more holistically about how we bring communities in. I think the corruption issue will park because we know that's, rather knotty. But if from your learnings and using regenerative design principles, how do we move from where we are, which is clearly in a state of crisis and responding to all of these issues, to a place where we can start solutioning together, moving as a community, local government and the private sector to find solutions? Where do we start?
I think the communities need to be educated on why certain projects are being undertaken. I think in a lot of cases this is very, very, very poorly communicated on a number of projects we've worked on and are working on, where the taskmasters are not communicating that correctly, and that then ends up as a discord within the community, and everybody wants their piece of the action and doesn't feel included. So the messaging is extremely important, and the community understands why certain projects are being undertaken and what their benefit from this project is.
Yeah. And Rowan, from your perspective?
The country need and the sort of engineering and decision makers behind bulk infrastructure and water management need to acknowledge the work is not only at plant level. And when I talk about plants, I'm talking about wastewater and drinking water plants, but so too the environment in between that.
Correct.
So there is clearly focus on rehabilitating these waterworks and the infrastructure, the reticulation. These are all capital projects. These are 5 to 10 to 20 year programs. We have a problem now. It's not just at the plant, it's in the environment. The environment needs active management and rehabilitation. A lot of our waterways, particularly up in Gauteng, are man-made systems. These are rivers that have changed drastically from what they were meant to be or how they started. We've dammed everything up, and we cannot expect it to just look after itself. particularly with the breakdown of infrastructure. So there needs to be focus and investment at plant level, but so too recovery and rehabilitation in the environmental sector, because particularly up in Gauteng and at these away from the coastal regions, we are in a very tight loop. Our drinking water is very, very close to our wastewater, and we're expecting the environment to attenuate those problems. We passed that milestone a while ago.
Yeah, in fact, it was actually a feat of engineering that just due to gold that we managed to engineer these water systems, the largest city not near a naturally occurring river or lake or next to an ocean. But now we need to deal with the fact that as mining recedes, we're left with all of these externalities from mining. I mean, AMD was a big issue 10 years ago. I'm sure it hasn't gone anywhere, but all of the public attention now seems to be on the collapse of infrastructure and in particular wastewater treatment facilities. What happens when those two issues converge, right?
Agreed. It's spoken about less, still a problem, superseded by the big nutrient issue and the big wastewater issue. The approach to dealing with AMD, there has been many successful AMD treatment solutions put in place, which has reduced some of the loading issues. But the way you deal with an AMD water issue and the way you deal with a sewage and nutrient issue are pretty different. And if we have those streams converging, like we do have in many river systems, it compounds the challenge of how we rehabilitate and how we deal with that water.
Sure.
One of those streams are much easier to deal with than combined.
Again, stressing the urgency of the challenge. Now, Heiner, I know you've worked across multiple geographies, the US, Germany. What can South Africa learn from international markets? I know we have our unique challenges. Are there things we can replicate from elsewhere? And conversely, are there areas maybe where we're actually leading, given our unique challenges that we've had to deal with?
I think, that's a very good question. So I think to answer that, if we have a look at our technology providers or suppliers from the US that we use, the technology has been developed based on US/European and first world sort of countries where their problems, in their assumption, are very big problems, but their loading is minute compared to what we have in this country. And I think in South Africa, we're certainly leaders globally at finding solutions to deal with really extreme problems, because the pollution that we have in South Africa, or throughout Africa even, is nowhere close to what is being experienced overseas. So there's a learning taking place between us and our colleagues overseas and the universities we're working with overseas, who are leaning on us and saying, how far can we push this technology with the results that we're achieving in country?
That's fascinating. Bionomics is something that you at Blue Planet really are pioneering, and you mentioned it early. Can you just explain and expand on what that philosophy really is at its core?
So Bionomics is the learnings over many, many years working with biostimulation, which Rowan alluded to earlier on, creating the right conditions for bio-augmentation and bioremediation to take place. We've, over the years, been exposed to many different products, many different approaches, and we've built up a bank of knowledge and IP and also understanding of how technologies work. So we have, if you're looking at a painter or an artist, he has a palette of colors, and we have a palette of approaches. And then we look at Bionomics as having a system architect, which Rowan, for instance, heads up for us, is to have a look at the best solution for that bespoke problem, because every single water problem is different. Mm-hmm. You have a mix of AMD and nutrient-rich water. So we've developed this palette of products where we have got the insight into what they actually do and understanding how they best give us a result. And I think Rowan will be able to take you through Bionomics Flow and the various different approaches that we have developed for different market sectors, because, as I said, none of them are the same.
Rowan, what does that entail? And I also want to come back at a very high level and get your opinion on, can we fix Hartbeespoort Dam, for example? Can we ensure that the Vaal system gets ahead of the water lettuce problem? But firstly, at its core, how does bionomics work from your perspective?
As Heiner said, it's the methodology of working with key technologies, the theme of which is always biological, working with nature. We cannot solve these problems at scale by throwing more chemistry. And I liken it to if you're familiar with the gut microbiome and general health, if you're suffering from acid reflux, sure, you can take an antacid and get temporary relief, but or take a drug to deal with that. But what was the underlying root cause of that? And if we get that biological system right, like in good gut health, and stop trying to throw drugs at the problem and fix it holistically, we move the needle significantly. And the bionomics approach we package into different verticals based on where the challenge is. So we have a program for rivers, Bionomics Flow, where we take these learnings and these technologies in the form of the correct microbial consortiums, some bioengineering, working with wetlands, taking invasive wood species, turning them into biochar, inoculating that with beneficial bacteria, putting nanobubble technology in, and it's more than the sum of its parts. I think that was the first learnings when you first started working with the tech. 1 + 1 equals, it looks like 7 sometimes. We're doing more with less.
It sounds very circular as well, I mean, with the biochar example, which gives me some hope. It says that, right, we have solutions. Ultimately, you don't want to be in a position where we're putting out fires all the time. So we really have to start thinking about what we're discharging into the environment and why we have this high buildup of heavy metals and phosphates and all the rest of it, and over neutrifying our water systems. But if we now have to go and say there are problems that need to be fixed, how do you do that at scale? And who funds that?
Yeah, it'll come down to obviously the geography of the area and the stakeholders. It normally starts off with the stakeholders or who is impacted by this issue, and it's generally going to be a mix of government and private. We've got experiences. I'll relay a story where there was a drive from a private housing estate impacted by a public and social issue. It's a heavily impacted river. It's known as the most polluted river in the Western Cape, the Soot River, not so soot anymore. So basically, that is quite a small system. It ultimately runs through a upmarket golf estate and onto the ocean in Strand. And a few years ago, there was a land grab from the Sanrail earmarked land where the new N2 is going to be. So informal settlement sprung up, no formal sanitation, no formal infrastructure. The river became the dumping ground and the sewer system for over 40,000 people. That river affected not only that community, but so too many diverse income level communities all the way down to the beach. It became essentially inhabitable to be around that river. It was a grey to black stream devoid of life with dangerous levels of hydrogen sulfide, no bird life, no aquatic life, and no one even wanting to be close to it.
Probably the only area in Cape Town where property prices were going in reverse.
Yes, I believe so. They were losing property valuations. Sales had stalled in the area. And because it's a complex issue in terms of social, in terms of government, the municipality and the city by rights couldn't put infrastructure down because it wasn't their land. So it was all around challenging for everybody, and with no apparent way to solve this from an infrastructure point of view, the residents at the end of the river before the coast approached us, asked, what can you do to solve this for us? No one else seems to be helping. That if they tried a few approaches, they tried some basic bioaugmentation, they tried chemistry, nothing was helping. We designed the Bionomics Flow concept for them, proposed it to them. implemented it and basically we could only work within the bounds of that private property, the last 300 meters of a river. If you speak to anyone in a similar field to us, this is an extremely challenging project because we don't have contact time.
Upstream, you just being,
It's the water's moving fast. We've got to change that water quality in a matter of meters in a flowing river. So from an engineering, biology and chemistry point of view, extremely challenging. Nanobubble technology and the correct microbes delivered. We prevented all their odors. Bird life started coming back in 5 days. The upstream infrastructure problems actually started getting worse. Sewer breakdowns, sewer collapses started appearing and increasing the loading. And we've been able to keep that place free of hydrogen sulfide, instill some life and biology in the system again. We're seeing speciation, we're seeing fish, we're seeing bird life, and importantly for those private residents, they don't have those odor issues. And the byproduct of that program that was privately funded to essentially get them relief from odor is actually reduced the water pollution in terms of COD and nutrients by 70% before it hits the ocean. Wow. And that was completely privately funded. What everyone thought was impossible at the time now it was shown to be possible. And that got the ears and eyes of government and municipalities to say, okay, these kind of problems can be solved. Let's look at it.
Right. So are you now working more closely with the city of Cape Town on this?
We're working with many municipalities across the country. So some of the departments that have got dedicated R&D within their water and sanitation divisions are working with our technologies and approaches. And it still needs adoption from an engineering point of view and an endorsement. Our engineering community in water and sanitation is very traditional. We're doing things the same way it was 40 or 50 years ago. Mm-hmm. We're changing now. We have novel issues novel challenges that need novel solutions. So the book's getting rewritten, so to speak. And we would like you to go faster, but the wheels are turning.
But that kind of systems change, I often liken it to changing the culture inside an organization. You know, an organization has natural antibodies, and you're trying to introduce something new, and the organization almost deploys those natural antibodies to any kind of innovation or anything new. How do you change the system, and how are you finding that, Heiner, as you start to try and mainstream these technologies?
So we spend a lot of time, with consulting engineering groups, educating engineers, water engineers, with water bodies. Be it Magalies water, be it Mgeni water, be it Ekurhuleni, doesn't matter. You know, these have scientific services whom you can work with, and it's about teaching and educating people that there are alternative technologies out there and that they don't get shut down at the engineering phase already. Because as Rowan rightfully said, these engineers, a lot of them are very set in their ways and not open to new ideas. Bricks and mortar is the way to go. Yeah. And it's the way the industry has been built. But we can't keep doing the same thing and expecting a different result.
Definition of madness, isn't it?
Yes.
So as we wrap up, the future of water has been our kind of payoff line in this series. So if you were to say the future of water what is the future of water, and what role can the private sector play in helping being part of the solution rather than just shrugging its shoulders and saying, well, it's not our problem?
A few answers to that. I think something I'm quite passionate about and I want to raise is from a consumer behavior point of view. Think about what we're flushing down. Sanitation, was more straightforward decades ago. The personal care products, the products we use in our homes, take a look at the ingredients, educate yourself. We should be looking at more stringent standards in this country on consumer products like high phosphorus products. Look at having phosphorus control like they do in Europe and the US. So let's think about what's going down the drain and the impact. The future of water on a greater scale really is the reduce, reuse, recycle. We're going to see advancements in recycling. We are essentially, particularly up in Gauteng, indirectly recycling our water already. Consumers need to have acceptance that we will have direct waste to drinking water recycling happening in the future. This is on the books for City of Cape Town.
Yes.
There is kickback from society saying this is going to be dangerous. It's inevitable, it's going to happen, I believe. We need to get on board with that, but so too we need to push governments and regulation that we can trust that water and trust that infrastructure that's doing that work.
Yeah, I think it's hugely empowering knowing that I, as Michael Avery, can go home and make an impact just by choosing different products, choosing wisely what I consume, how I consume it, and how I dispose of it. Heiner, from your perspective?
Yeah, I think triple Ps are also the future of water, bringing in the private sector, bringing in the blue chips, bringing big business into playing their part in the rehabilitation of the current problem that we have. Rowan rightfully again earlier said there's a lot of plans to build a lot of stuff. This takes 5 to 10 to 15 years to do. Our environment cannot take another 15 years of abuse. It will collapse, and it already is collapsing. So I think big business needs to play a role, not just make sure your water discharge from your facilities is compliant to discharge standards for municipal uptake, make it better so that we're diluting the problem already going to a wastewater treatment plant. Play that role in making what you're discharging better. Be in the foreground, be part of the solution, not just a user of the system.
Heiner Dominick, thank you very much. And Rowan McDonald, I've always believed that water is actually a great unifier. I know we've seen up in the north of Africa what's going on between Egypt and Ethiopia over the new dam. But I think, and I believe, it actually brings people closer together because it is one of those things that is foundational to life. Without it, we all die. It's one of those. Thank you very much. It's been a fascinating conversation. Thanks for joining us on the podcast.
Thank you.
In a world where water scarcity is one of our greatest risks, innovation is proving that resilience doesn't always mean choosing between nature and technology. It means bringing the two together. Ecological engineering, bioremediation, and advanced biotech aren't just theories, as we've heard. They are already delivering very real-world impact, from wastewater reuse to ecosystem restoration. These approaches show us that sustainability and scalability can coexist, and that the private sector has an extremely pivotal role to play in re-engineering our water future. Whether you're a policymaker, business leader, or a citizen concerned about our future, resilience grows when innovation and nature flow together. A heartfelt thanks to Heiner Dominick and Rowan McDonald from Blue Planet South Africa for sharing their knowledge and their vision and their passion for the space. This has been the Safripol Water Security Engagement Forum with me, Michael Avery.